Morning, Minister, colleagues in the fellow industry, Chairman. I'm Frank. I'm representing Sunseap. So, wow, what a year! And I was just chatting with some colleagues to say, yeah, this is also one of the new practice. Say that I have not been back to this building for almost a year, and in the last year I was here at very different ACES. So this year, I think traditionally, in every ACES, we will always use this opportunity to share about our kind of a report card for the year for Sunseap. Of course, this is a very different year, and we are focused on 4 markets, namely the markets that have performed, I think, better in the COVID pandemic situation. So China, we have signed with a company called Jiangsu Tietia. It's a China tower for their 5G networks. We are actually installing solar panels to power part of their 5G networks in the Jiangsu area. In Taiwan, we have won a tender called Yunlin province, right? In the Yunlin province, it's somewhat like the Solar Nova equivalent, setting up solar systems across 100 over schools in Taiwan. In Vietnam, we are completing a project development for 350 megawatts of utility scale. This is on top and above our 168 megawatts of utility scale that's been completed in Vietnam. So we are also pursuing other CNI Fit2 rooftop solar systems in Vietnam as well. Now back to our tiny red dot. This year, it's going to be different because we don't have a real report card to show you because we didn't construct that many solar systems in Singapore this year. But I want to zoom in on one specific project, that is our Woodlands floating PV project. This is one project that we have completed this year. And in each of the slides, I'm going to use one keyword to illustrate, I think, the transformation that the clean energy sector is going through as well. So the first slide, as you can see here, the keyword for me for this slide is really community. All right, you can see from the photos, you have people installing. What is different is this happened during the circuit breaker. All right, so traditionally we will use subcontractors who will in turn use foreign workers to execute and install majority of our projects here. So what you see here in the slide is none of those foreign workers because we have no foreign workers available to us during circuit breaker to do the installation. Instead, I did ask the office to volunteer. So my office of colleagues, these are your typical engineers, drafters, white collar basically, all right? We asked for volunteers. And I was surprised I got a good response from them to actually do the installation during the circuit breaker. Maybe they were too bored at home, right? But I think they persisted, right? I was down about 5 times to the site during the 2 months, and a lot of my colleagues were there almost every day, right? To really participate and move on the installation, and even without so-called help from our contractors or foreign workers colleagues. I think that this sparked off an idea, right? Could we actually use and train local labor to do our installation? Basically build our own solar system with our own hands, right? And that led on to ideas about, whether we can actually train our local workforce long term. Because as you can imagine, the foreign worker workforce is actually a transient workforce. They come, after a few years, they go back. But so a lot of know-how that we have trained our skilled workers have been lost, right? Because, again, it's a transient labor. I think we are very happy when Minister Chan announced about the front loading of the 2025, all right, to achieve 1.5 gigawatts. I think this is really exciting for us because when you accelerate the entire solar development, or I call it sustainable infrastructure, front-load it, you create jobs. And these jobs, we did an estimate on this, right? So every 100 megawatts, you probably need about 150 manpower of different positions, right? You have majority installers, all right? You have your project managers, you have your draftsmen, and you have your project directors, right? Different positions, but almost every 100 megawatt is about 150 people you need to install. So if you're looking at front loading for the next 5 years, we are probably creating jobs for near to 4,000 people. All right, and to start off, I think we have reached out to NTUC, all right, E2I, and we are in the midst of hiring 300 people, all right, locals, to help us with the installation. Again, for our next year's target, we want to do 200 megawatts here in Singapore, minimum. Again, the whole idea of can we actually train locals to actually take up these jobs? Is this a job really for the general worker or the construction worker? I think there's some need for a mindset change here, right? Because most of the time we think of our foreign workers as typical general worker. So maybe faceless, nameless, a lot of things you are careless. You are careless about what exactly happened on site. You just want the job to be completed. But I think all this will change, right, when we hire a local skilled labor, right? Because we will invest training into the individual. We want to provide a career path for the individual and maybe in future even deploy them in our overseas projects. The solar equipment that we actually deal with on a day-to-day basis is actually not your typical brick and mortar, I would argue. All right, the equipment that you carry, the solar panels, each piece that you carry is a few $100s. The solar inverters is a few $1,000s. Right, so we require skilled labor to actually do the electrical work. So it is not really a general worker per se. So really, community, I think we can build a community around a few thousands of skilled labor here, who also will in turn be our ambassador, right, for clean energy. The next slide I want to show you is also part of the Woodlands project as well. All right, the keyword I want to use here is connectivity. All right, this, as you can see, the project on the DC side is already completed. All right, it comprises of 15,000, roughly about 15,000 panels to make up 5 megawatt. This is a specialized pontoon, right, that we are using. It's not an off-the-shelf. We actually design and manufacture these pontoons to actually sustain 1.5 meter wave height. All right. We also utilize bifacial panels in this particular project. So the solar energy that's generated is not just on the front side, but based on the reflectivity from the water, you actually generate power on the back side of the panel as well. And with this connectivity, I think it just reminds me of what Minister Chan talked about in terms of the interconnect via Malaysia, between Singapore and Malaysia. That is a trial that is happening. And this trial, 2 years of a pilot, well, I think we can try to work around that. We have been very active with working our partners in the north to see whether we can make this a green interconnect. So 100 megawatts AC, right, is the current RFP that Minister announced. That we did also some math. That 100 megawatt AC is roughly about 800 over megawatts of watt peak of solar energy. So in fact, we were chatting with Minister earlier about whether this will actually displace some of the Genco's business here, right? Possible, but I don't think the Gencos here can generate green power, which is what really the industry needs. Which industry needs green power? We have seen a huge rise in terms of demand from data centers. A lot of data centers have approached us to say, hey, we will need green power. Probably is because due to the moratorium that was recently set, without a green DC, you can't even build a DC now. All right. So I think this 800 over megawatts, once the RFP is out, this 800 over megawatts of solar energy, right, this is actually our proposal, right, can actually feed the demand of quite a number of DCs here. The last slide that I would like to talk about is this barge, right, and the keyword for me is transformation. This barge, the previous slide, you see a lot of cables coming back, right? All the cables go to the other side of this barge, right? And you see in this picture, only one cable, this single cable is actually a subsea cable that goes and buried into the sea and comes up on the Singapore main island and got connected to a substation nearby. All right, so this serves a few purposes. You zoom in, all right, to the slide itself, you will see that in the middle of the barge, there's a transformer. This is where we house the floating transformer. Two sides to the transformer is your ACJB. All your switch gears are there as well. So literally, this whole farm is floating on water, not just your solar panels, but your transformer is also floating on water as well. Now, what is interesting to me and why I call this transformational as a keyword is, on top there, you see that is actually a 240-footer right in the middle, on top. So we designed this in a specific way such that we can change this 40-footer like a module. All right, this 40-footer can be, now it's a visitor center. All right, we designed it to be a visitor center. If you want it to be a military base, you have a different module. You want it to be a nice house with a sea view, you have a different module. Right, you can transform different modules here. You can also put in batteries to have a self-sufficient system. So the whole idea of this project is to showcase that you can actually live, work on water. And where there's energy, right, you can generate power, you can work and live there. Now the keyword transformational to me is also two things, transformation in technology and transformation in mindset. All right, so in technology-wise, I think this year, despite the pandemic, we created quite a few interesting technologies. I think to start off, we talk about the grid-level battery systems, or ESS. I think last week we made an announcement, together with Singapore Power and EMA, that we've commissioned the first grid-level battery in Singapore. It's a 2.4 megawatt-hour battery in one of the substations. So that particular project will allow us to study, I think, how we control intermittency, how we can actually make use of different applications that ESS can provide. Whether is it in terms of energy arbitrage, can we, do contracting, shave off the peak power to reduce contracted capacity, right? These are a few ideas that we have. Again, the question is, where do you place all these batteries? This is just the first one, right? Where can you imagine where you can put all these huge batteries? The 2.4 megawatt is roughly a 20-footer, right? So in our mind, I think the place to replace those batteries is actually the diesel genset in most of the buildings in Singapore, right? According to SCDF regulations, we have a diesel genset, maybe two or more, sitting in every building. Other than HDB and a shop house, you probably find a diesel genset and a tank to store the diesel somewhere in the basement. So we believe that is the place that you can eventually replace with a battery. I think other technologies like energy intelligence, we have also designed an algorithm to track and desegregate incoming power data. Meaning to say, most of the time, we want to do a pulse check on a building. You can't because you need to install sub-meters everywhere, or you need to collect a lot of building BMS data. So now with these energy clamps and this algorithm, we can desegregate energy, right? The incoming loads through an ML process, we will actually know the different sub-loads by recognizing the energy signature. So the other things like EV charging, which my colleague, I think Ji Kyung, will be presenting later in the later panel. We have designed also a slim charger, right, with software specifically for the Singapore environment, where you have tight parking spaces. But more importantly, I think in terms of transformation, is really about mindset. This is the year I think we get to reset our mindset. A lot of customers who used to sit on the fence, I think they are now moving towards the idea of sustainability and clean energy. I think they realize that their demand for clean energy actually result in us, a developer like us, physically building even something like this, what you see on screen, right? So really want to thank the government actually for front-loading, creating jobs, addressing unemployment, right? Changing mindsets. I think really this is truly a bright green spark in a tiny red dot. Thank you.